Hello, welcome to the NMR Spectroscopy course. This is the third lecture of the NMR Spectroscopy, and in this lecture we will study the advantages of the NMR Spectroscopy, and then we will study about the chemical methods. Those were the conventional methods used before the NMR, and what are the disadvantages of these methods. Actually, these were used before the NMR to study the structure of the compound, to verify the compound, verify the product, that this is the product of the reaction, or this is something like a byproduct or any other product. Then we know that NMR spectroscopy is used for the configurational and constitutional analysis. So let's go to the practical part, and first we will study a reaction known as the nitration. So this is acetophenone, ring, and we react it with the nitric acid. When we react acetophenone with the nitric acid, nitration occurs at the meta position. This is a meta position. So always nitration occurs at the meta position conventionally, but how to verify this, that the meta position is nitrated? So we can give this answer by using the NMR spectroscopy. So in another reaction, this is the epoxidation reaction, in which norbornadiene. I am writing these names because you can search on the internet about these molecules. When epoxidation of the benzonorbornadiene occurs in the presence of MCPBA actually metachloropyrbenzoic acid, MCPBA. So when the nitration occurs, there are three possibilities. This is the endoisomer, and this is the exoisomer. So there are three possibilities, that endoisomer may be formed, exoisomer may be formed, or both of these may be formed. If both of these isomers are formed, which is the major product and which is the minor product? So in order to verify these, which is the major, which isomer is formed in the major quantity, which is the minor quantity, we can do this by using NMR. So if you don't know the difference between the endo and exoisomers, you can watch this video. This is given pop-up window, a card. You can click on it and it will refer to this video. You can easily differentiate between the endo and exoisomers. So this is endo and this is exo. So by using the NMR spectroscopy, we can differentiate which product is formed. So in the next, this is a reaction. This is actually bromocyclohexane. Not a reaction, but it is a molecule that is used as a study in the NMR. So we know that in a cyclohexane ring has two types of the protons, one at the equatorial positions that are known as equatorial protons, and one at the axial position. If you don't know the difference between the equatorial and axial protons, you can watch this video. You can I assure you that in 5 minutes you will get an idea what is the equatorial and what is the axial, because it is difficult to teach you in the two-dimensional picture. You can watch a three-dimensional video, so in which I have used a molecular model to teach you how you can differentiate between the equatorial and axial position. So when a substituent attached to the cyclohexane ring, it always prefer the equatorial position. So how to verify that, how to verify the result? This is the correct one. So we can use the NMR to verify these results. So I am talking about the advantages of the NMR. What are the applications of the NMR? Next is about the chemical method. This is an example of the old chemical methods that were used when the NMR was not available. This is a cyclobutene. So we have receive a product, like we conducted a reaction in the laboratory and we get a cyclobutene, but we don't know that this is a cyclobutene because this is a reaction given, but in the laboratory when we made a product we don't know about its structure. So we got the product, then we reacted with the ozone. So when we reacted with the ozone, a dialdehyde is formed. Dialdehyde. When we do the oxidation in the presence of the KMnO4, KMnO4 is an oxidizing agent, and oxidation of the dialdehyde occurs to give us a dicarboxylic acid. This carboxylic acid is known as succinic acid. So when we got the succinic acid, this product, we will compare it the product which is available in the laboratory. If the properties of both the chemicals are the same, then our product was this cyclobutene. So our successive reactions, we got that our product was right or wrong. So this is also a wastage of the chemical. We use ozone, we use KMnO4. So it is okay, we can afford that, but it is time consuming. It is a time consuming method, but by using the NMR method we can get the structure of this product, get an idea about it in very efficient way, and very it is also not time consuming. And this is a simple molecule, we can get its chemical analysis, then it's okay. But when we have the complex molecules, we can't do its chemical method analysis. We have to use the NMR to elucidate their structure. So except elucidating the chemical structures, we can do the study the dynamic process by using the NMR. Like we can study the we can obtain the NMR spectra at different temperatures of the molecule, and we can also get an idea about the bond length, bond angles, etc. Bond angles. So these were the some advantages, and these are the some disadvantages of the chemical method that were used before the NMR, and how NMR is beneficial for us and how it is quick. So this was an overview. So if you have liked this video, then please subscribe my channel. In the next video we will discuss more about the NMR. So this is a full course of the NMR. You can watch all the videos to understand the NMR completely. Thank you so much for watching the video. Let's meet in the next video.